Welcome to the deep dive. Today, we're looking into something really critical for AI, making it more reliable. We've got a stack of sources here suggesting that maybe, just maybe, the key isn't some huge leap in power, but actually,
Mm.
well, something simpler. Structural humility, you could call it. Yeah, the sources are proposing this deceptively small architectural change, but it could have a massive impact on that problem everyone worries about. LLM hallucinations. And we're not just talking small mistakes here. We mean AI confidently making up legal cases, maybe even fake medical stuff. So our mission today is to really unpack this idea. How can we structurally enable AI to just say, I don't know?
Okay, let's get into it then. What if the secret to making AI truly trustworthy, especially for important things like law or health, isn't about endless fact-checking, but, well, genuine digital humility,
Yeah.
built right in?
It's a huge issue, right? Because we, as users, we tend to think these systems know things,
Yeah.
like really know them. But when they hallucinate, they often sound so certain. And that creates this dangerous illusion of knowledge. It's not just wrong, it can be actively harmful. Like those stories about lawyers using AI, citing court cases that just didn't exist.
Exactly. And that has real-world consequences. People could get sued or, make terrible decisions based on pure fiction presented as fact. That's the vulnerability we need to tackle.
Okay, so to fix it, we need to understand why it happens. Why does this confidently wrong behavior seem baked into the system? It comes down to the basic design, doesn't it?
Absolutely. It's fundamentally tied to the transformer architecture they're built on. These LLMs, they aren't like search engines. They don't have access to like a database of facts or objective truth. They're basically incredibly sophisticated statistical machines. Pattern matchers, really.
Statistical predictors, meaning it's all about probability, what's the most likely next word, that sort of thing.
Precisely. That's the key difference.
But if it's just predicting probabilities, why doesn't it, I don't know, just stop when it runs out of good options? Why invent stuff instead of just pausing?
Well, that's the core vulnerability, is how we designed them. The model takes your prompt, your input tokens, and then it predicts the very next token that's statistically most likely to follow. Then the next, and the next. It builds the response step by step. But the system is built to always give you a coherent output. It has to complete the thought, essentially.
Always, even if it's unsure.
Yes. Imagine it crunching through billions of potential sentence paths. Now, if you ask it something niche or really fact-heavy, it might find that all the statistically likely paths have, well, pretty low confidence scores attached. But because the machine must produce an answer, it's forced to pick the path that's, let's say, the least wrong statistically, even if finishing that sentence requires it to plug in made-up details, a fake date, a non-existent legal citation, whatever fits the grammatical structure.
So it prioritizes fluency over facts when forced.
In a way, yes. It lacks that I give up button. There's no built-in circuit breaker for when its own confidence drops too low on factual matters. That's the fundamental problem.
Right. It's a design choice, almost. We built this powerful thing that, when cornered by uncertainty, is architecturally compelled to, well, to bluff confidently. So the simple solution in the sources is basically about installing that circuit breaker, giving it the structure to just refuse.
Exactly that.
Yeah.
And the proposal is quite elegant because it doesn't mean rebuilding the entire LLM from scratch or trying to feed it constant external knowledge checks. Instead, they suggest pairing the LLM, the generator, with a second, smaller component, a dedicated piece of architecture called a discriminator.
A discriminator, okay. Sounds like some kind of quality control, like an editor sitting between the AI brain and the user.
Well, that's a pretty good way to think about it.
Yeah.
But here's the really crucial part. Its job isn't fact-checking in the human sense. It's not going out to the web or checking a database to see if, Lincoln was shot in 1865 is correct. Its function is different. It estimates factual risk.
Factual risk. What does that mean in practice?
It means it assesses the likelihood that the answer the LLM just generated contains statements that should be fact-checked, things that, by their nature, demand objective verification.
Okay, that makes sense. So it's looking for types of information, not verifying the information itself. Like what specifically?
This is where it gets clever, the mechanics of it. The discriminator is trained to spot the features of factual claims, not the facts themselves. So one thing it does is use named entity recognition. It flags specific things like dates, names of laws, chemical compounds, job titles, tokens that usually signal a need for factual grounding.
Things that aren't subjective.
Right. And second, it looks at something like reference density. If the LLM spits out a paragraph stuffed with, say, 5 specific dates and 3 expert names, well, the combined risk there is much higher than if it was just generating, like, a general opinion piece.
So it's analyzing the ingredients of the answer, checking if it's using too many high-risk words or structures, especially if the LLM's own initial confidence score was maybe a bit shaky.
Precisely. It looks at that combination. Are there lots of factual-sounding claims, structurally speaking?
Yeah.
And was the generator's confidence low when producing them? If the discriminator flags that combo high factual risk markers plus low internal confidence, that's when it triggers the safe fallback. Internally, the LLM might still have produced its potentially dodgy answer, the fake legal argument or whatever, but the discriminator steps in right at the end and swaps that output for a simple, honest, I don't know, or maybe I can't confidently verify this. It's the final gatekeeper.
Wait a second, though. If the
Yeah.
let's call it the bad answer, is still generated behind the scenes, aren't we just hiding the problem? Couldn't someone maybe try to trick the system, like with prompt injection or something, to bypass that discriminator layer and get the risky output anyway?
That's a really important question. And yeah, the authors definitely acknowledge that. They're clear. This isn't about eliminating the hallucination itself at the generation stage. It's about containing the failure mode, preventing the system from confidently outputting dangerous falsehoods to the user, especially in those high-stakes areas, law, medicine, finance, which is where this research is really focused. You're designing for integrity and safety first.
So the discriminator needs to be really tightly integrated, like a mandatory final check.
Exactly. It's meant to be a non-optional filter in the output pipeline for these kinds of applications. Look, the goal here isn't creating an omniscient AI. It's about preventing harm in practical situations. For a medical tool or a financial advisor bot, containment is a huge improvement over confident fabrication.
Right, right. Containment, not perfection.
Let's talk context then, because obviously you don't want this firing all the time. If I ask it to, I don't know, write a fun story about penguins flying to the moon, I don't want it saying, I don't know, that lacks factual grounding. Well, of course not. And the discriminator is trained for that distinction too. It learns to tell the difference between high factual risk scenarios and low risk ones. So if you ask it to summarize text you provide, or brainstorm ideas, or write that fictional dialogue, those are low factual risk tasks. The value there is in creativity, summarization, that sort of thing. The discriminator sees fewer of those high-risk factual markers. The generator's confidence is probably fine. And so the I don't know option stays quiet. The system should, ideally, self-regulate based on what kind of answer is being requested.
Okay, that helps clarify. Let's maybe use that image classification analogy the sources bring up. I thought that really hammered home the statistical trap LLMs fall into.
Yeah, it's a good one.
So you train a simple AI model just to recognize cat or dog. Only those two labels exist for it. Then you show it a picture of a horse. What does it do? It has to pick one of the two options it knows.
Right. It'll guess. Maybe dog, because of the legs or fur. And it'll likely state its guess with high confidence, even though it's completely wrong. It doesn't have a neither option.
And that's basically what the LLM does with difficult factual questions.
Exactly. The paths in its statistical training data that lead to the correct factual answer might be weak or just not there for niche topics, but it can't just stop. So it follows the high probability sentence structure, the way a confident answer sounds, and fills in the blanks, the names, dates, whatever, with statistically plausible but potentially fabricated tokens.
It fakes the details to maintain the confident structure.
Pretty much. So a better, more robust system, like the one proposed here, needs that third option, an explicit uncertain or none of the above category. By giving the LLM architecture the statistical equivalent of that, the choice to say, I don't know, we stop forcing it into that false binary, cat or dog, true or fabricated. Sometimes admitting uncertainty is the safest and actually the most correct response.
Okay, so bringing it all together, what's the big takeaway for us as people trying to understand and use this tech?
The real appeal seems to be how.
Yeah.
Relatively simple, this fixes. It targets the core failure without needing a complete AI redesign. That really is the aha moment, isn't it? It's pragmatic. You don't have to rebuild these enormous foundational models. You don't need constant slow calls to external databases for every single query. It's designed as an efficient internal safety valve, focused purely on the integrity of the final output.
So it improves trustworthiness without sacrificing too much speed or requiring entirely new training paradigms.
That's the balance they're aiming for. Look, the authors aren't saying this solves, the philosophical problem of truth in AI or anything that grand, but it's presented as a realistic, tangible first step, a way to rethink AI verification, especially for specific sensitive jobs where reliability is non-negotiable. It's about building AI that has some awareness of its own limits.
I like that framing, not a silver bullet, but practical progress. building in humility in a functional way through a statistical safeguard, a mechanism that allows it to admit ignorance when the internal signal suggests the risk of making things up is just too high.
And they mentioned they're actively testing this, looking for collaboration too. It's ongoing work.
It makes you think of that old saying, often linked to Socrates, I know that I know nothing. Maybe the most useful thing we can teach these powerful systems is sometimes the wisdom to just admit they don't know. Okay, so we've landed on this idea. It's about lightweight containment of the worst errors, not completely eliminating the potential for fabrication deep inside. So thinking about that trade-off, what stands out to you? What's the most critical area, maybe legal, medical, educational, where having an AI that can reliably say, I don't know, is absolutely essential, even if it means it's sometimes less helpful or slower? Something to chew on. Keep digging into that, and we'll catch you on the next Deep Dive.